Hi, welcome to the statics tutorials. So let's look at calculating some moments with some different cases with two-dimensional systems. So in the first case, we just have a bar and then we have a single force of 251 newtons at a distance of 0.3 meters from A. The whole bar is 1 meter, so it's going to also be 0.7 meters from B. The force of 251 only goes in the y direction, so using the method for 2D, we'll have this force in the y direction times this x distance, and that'll give us the moment about A. Now we have to decide, is that going to be positive or negative? So if we try to make it positive, our fingers are going in the opposite direction of the 251. If we make our finger negative going into or thumb negative going into the board, then we can put our fingers in the direction of the 251. So it looks like this moment created by the 251 newtons is negative about A. And then just doing this calculation, minus sign in front because it's a negative moment, not because it's a negative force. Negative moment, 251 newtons times the 0.3 meters. So remember, this is force in y, distance in x. The force and the distance always have to be perpendicular. And this gives us negative 75.3 units of just newtons times meters, so newton meters. If we want to calculate the same moment generated by the force, but about a different point, we could pick B. And then in this case, we have to figure out the sign as well. So over here at B, if we make our finger go in the positive direction, then our fingers here are going in the same direction as the 251 newtons. So this is a positive moment. So the moment about B is positive. 251 newtons times 0.7 meters gives us 167 newton meters. Now again, if you prefer to think about clockwise and counterclockwise, just draw the diagram, stab your paper here with your pencil or pen, push on your paper in this direction, and you'll see that the paper spins around A in a clockwise direction. Remember, clockwise is negative. Clockwise is negative. So that's our negative moment about A. And then if you pin your paper here at B, just by stabbing in your pen or pencil, and you push on your paper over here, it's going to spin your paper around in a counterclockwise motion around B. And remember that counterclockwise, CCW, is positive. So that's why we get a negative moment here and a positive moment here. Let's look at another system, but let's make our force go in the x direction. So we have this beam that has a 90-degree angle on it, and then we have a force in the x direction, 201 pounds. Let's calculate the moment about A. This is an x force, so we need to multiply it by a y distance, and we need to figure out whether this is a positive or negative moment. Thumb into the board or into the paper allows you to put your fingers going in the direction of the 201. So this has to be a negative moment. Y distance, 1 foot. X force, 201, gives you negative 201 foot-pounds. Now let's calculate the moment of the 201 about point B. Thinking about point B, thumb into the board allows us to put our fingers going in the direction of the 201. So this is also going to be a negative moment. It is still an x force. We still need to multiply it by a y distance. The y distance is still exactly 1.0. So strangely enough, moment about B is going to be exactly the same as the moment about A for this case. Minus 1 foot times 201 pounds gives us negative 201 foot-pounds. Now let's look at a slightly more complicated example down here. So we have a beam that's kind of an inverted T shape, and then we have a force that's going in both the x and the y. So 751 newtons at an angle of 30 degrees under the horizontal. Let's calculate our moment about A. So we can do this again by breaking this force up into an x component and a y component. So let's look at the x component first. So the x component is going to be 751 times cosine 30. So that's our fx. We need to multiply that by a y distance. This is our y distance that we're going to use. And then we need to figure out, is this a positive or negative moment? So if we're at A, thumb into the board allows us to put our fingers going in the direction of Fx. So this is a negative moment. Now we need to look at the contribution of the Y. So let me grab a different color. So we have Fy here. Fy is going to be F sine of theta. So this is our Fy over here in our equation. We need to multiply that Y force by an X distance. This is our X distance that we want to use down here, 0.450 meters. So that's our X distance. Now we need to decide if this is a positive or negative moment. Thumb into the board allows us to put our fingers going in the direction of Fy. So this is a negative moment. So both of these contributions are negative. When we add them up, we get 429 Newton meters. Now let's look at this moment about B. I'm going to erase my distances so I can reassign them. So with our moment about B, it's the same thing. We need a force in the X. Force in the X is still F cosine of theta. So this is our Fx. And we need to multiply this by a Y distance. This 0.4 meters is still the Y distance. We need to figure out a positive or negative sign. Thumb into the board at B means our fingers go in the Fx direction, so this must be negative. And then let's look at our Y component. So we've got Fy. Fy is still F times sine of theta, so still 751 newtons times sine of 30. And then we need to multiply that by our X distance over to B. In this case, now the 0.5 is going to be our X distance over to B. We need to figure out positive or negative sign. So looking at B, thumb out of the board, and come over here, allows us to put our fingers in the direction of Fy. So this means that this contribution winds up being positive. So when we add these two contributions together, we get that overall negative 72.4 Newton meters. Thanks for watching.